let's jump right in, because today we are diving into a literal giant of modern engineering, the Rooppur Nuclear Power Plant. Now, when you are looking at a facility of this sheer massive scale, one that's generating just unimaginable amounts of energy, the biggest question really isn't how you create that power. I mean, we know how to do that. The real question, and honestly it's a fascinating one, is how on earth do you control it safely? How do you manage this incredibly complex, highly volatile environment where there is absolutely zero margin for error? Well, in this explainer, we're going to unpack exactly how that's done. We're going to look inside the brand new technological marvel that was just hooked up at Rooppur.
2,400 megawatts. Just try to wrap your head around that number for a second. We really need to comprehend the sheer scale of what we're dealing with here. Built with Russian technology, the Rooppur plant is designed to house two Generation 3+ VVER 1200 reactors. And combined, they are going to pump out a staggering 2,400 megawatts of electricity. Now, these Generation 3+ reactors, they're specifically designed to comply with the absolute strictest international safety standards. But you know, having the physical hardware is really only half the battle. To actually harness that kind of immense, world-class power safely, you absolutely need a control mechanism that is just as advanced as the reactors themselves.
And that brings us to the ultimate solution, the APCS, or Automated Process Control System. Russia's Rosatom Nuclear Energy Corporation has actually just officially completed the delivery and installation of this fully automated system for the very first power unit at Rooppur. And honestly, this is a massive milestone. The APCS isn't just some, basic computer program you'd run on a desktop. It is a highly sophisticated, safety-critical digital network. Its one and only purpose is to automatically manage the complex operations of the reactor and, above all else, ensure absolute safety during every single millisecond it operates.
To truly get a sense of how this works, we can look at this brilliant biological metaphor from Syed Ahmed. He's the media focal point officer for the plant, and he hit the nail on the head when he said, "The systems act as the plant's brain." And that is exactly how you should picture it. Think about your own brain for a second. It's constantly regulating your heartbeat, your breathing, your temperature, all without you ever having to consciously think about it, right? Well, this digital brain does the exact same thing for the nuclear plant. It keeps everything strictly within safe operating envelopes. It is the central intelligence hub, continuously making autonomous, life-saving decisions.
But here's the thing. This digital brain isn't just a single massive computer sitting in a dark, buzzing room somewhere. Supplied by Rosatom Automated Control Systems, or ROSU, it's actually composed of 22 distinct, highly specialized subsystems. You can kind of think of these like the different lobes of a human brain, where each one is dedicated to a highly specific, totally critical task. Working together, these 22 subsystems cover the entire spectrum of automated process control and radiation monitoring for Unit 1's VVR 1200 reactor. It is this incredibly deep, highly redundant architecture, and it's designed that way so that absolutely no single point of failure could ever compromise the plant.
So if the APCS is the brain, then the thousands and thousands of sensors scattered all throughout the plant are basically its nervous system. This setup is constantly tracking temperature, pressure, flow rates, you name it. It is relentlessly monitoring equipment performance, the actual electricity being generated, and all the underlying technological processes. And it does this non-stop. Not just during everyday operations, but right now too, during the incredibly critical commissioning phases of the power unit. Literally, it feels every single tiny fluctuation inside that massive facility.
Okay, so how does this digital brain actually react when it senses something? Well, it's basically a reflex. Here's the rapid-fire sequence of events. Step 1, it monitors all that incoming sensor data we were just talking about. Step 2, it processes that data instantaneously through these highly advanced operational and safety controllers. And then Step 3, and this is the real game changer, it makes instant physical adjustments. We are talking about automatically moving heavy-duty valves and massive pumps in the absolute blink of an eye. There is no waiting around for a human operator to look at a screen and realize a pressure valve needs opening. The APCS detects the anomaly, calculates the required physical response, and just executes it instantly to maintain that perfect blanket of safety.
What's really cool, though, is that this project isn't just using standard, off-the-shelf tech. They are actually pushing the boundaries. Gleb Marashov, the managing director of the APCS division at ROSU, pointed out that they implemented several unique improvements specifically designed for Rooppur. For example, instead of the standard, bulky radiation monitors you'd normally see, they implemented a highly compact bench-type design for their automated radiation monitoring systems. And according to Marashov, this specific compact design is actually a world first for this type of system.
It's just a perfect example of how the Rooppur plant is really benefiting from cutting-edge, bespoke engineering. So, with all this incredible technology, where exactly does that put us on the overall project timeline? Well, back on April 28th, a massive step happened when fuel loading officially began at Unit 1. That one action single-handedly pushed the entire project into its operational stage. Fast forward to today, and we now have the complete delivery and commissioning of all the automated process control equipment. This fully functioning digital brain is right there at the construction site. The groundwork is firmly laid, the brain is awake and installed, and it completely shifts the project's focus toward its active future.
So let's step back for a second. Why does getting this digital brain online actually matter so much in the grand scheme of things? Well, the answer is pretty clear. The Rooppur project is widely considered an absolute cornerstone of national energy security. By successfully installing a control system that meets the highest, most rigorous international safety standards out there for a Generation 3+ reactor, it proves something really important. It proves that this massive influx of 2,400 megawatts of power is going to be both deeply reliable and entirely safe. It essentially cements the foundation for a much more secure, self-reliant energy grid for the whole country.
Which brings us to our final thought for this explainer. The hardware is in place, the fuel is loaded, and now this highly sophisticated 22-subsystem digital brain is fully online, constantly monitoring, thinking, and adjusting to keep everything perfectly safe. So I want to leave you with this question to chew on. With this absolute marvel of technology now awake and operational, how exactly will Rooppur reshape the future of national energy security? Because the scale of this project is truly mind-blowing, and honestly, its impact, it's really just beginning. Thank you so much for joining me today, and keep exploring.